Let's do the scavenger chain, I guess. What the hell is this going to be? Cough, cough. Or should I say... Yeah, it's getting a little drafty up here. Facilities management has been notified, but we still have work to do. Each pair on the floor contains 1. Data, the address of another one of the pairs, a scrambled chain. Each thing in the inbox is an address of one of the pairs. Outbox the data for that pair, and also the data in all the following pairs in the chain. The chain ends when you reach a negative address. Repeat until the inbox is empty. In other words, this is what's known as a linked list. Cool. Okay, so basically we grab... So the idea is we grab 0, so we go to E, we output E, we go to E's cons, and then we, from that, just repeat the process over again. So, basically we go from 13, we look at 13, 13 is S, so we output S, we looked at its cons cell, or something like that, I forget what the hell it's called. I think that this is known as the cons, and this is known as the something, I don't remember. But, whatever. The point is, this is like something that you learn probably in your 3rd week of computer science? I don't know. So, what do we need to do? First off, we need to copy a pointer somewhere. So, we need one, like, a little bit of extra memory. So we'll inbox the first pointer, and we copy it to there. So this is going to be called PTR. So 0 is the address of the first linked list cell, basically. And Bird made you buy this game. I didn't buy this game. So this is basically all we need to do, because it's only ever going to give us valid memory addresses. So there we go. This is basically our loop. Inbox, copy it to pointer, and then... So we'll call this init. And then we have our loop. And what we do is we copy from that... I guess... Do we really need to do this? I guess not. Maybe we don't need to do this. Well... I think we do, because when we do the outboxing, we're going to lose track of whatever our pointer is. So we do need a pointer variable. Alright, that's fine. So when we copy from pointer, that gives us we copy what pointer is pointing to. So that would give us that value. So this would give us E. We outbox it. We always do that. Then the next thing we do is we increment pointer, and then we copy from what pointer is pointing to. And if it's negative, that means we've reached the end of the chain, and we jump back to the init function. And if it's not negative, then we jump back to the top of the loop. I think this does it. So let's grab 0, we put it into pointer. We grab E, outbox it, increment pointer to 1, grab 13. Aha! So I forgot I need to then, if it's not negative, I need to copy what I'm currently holding into pointer. And then we do our loop. So we grab address 13 after doing that. So we grab A, outbox it. And I did not... Okay, so we grab address 10. Then we grab P, outbox P. Then we grab address 20, which will do E. So this will... Okay, this works. Cool. Alright, so that was our linked list. I guess it was about time for this thing to show up at some point in this dumbass game. That's cool. Linked lists are very, very interesting data structures. They're useful for a lot of different things, like building stacks, and queues, and a whole bunch of other stuff. I don't know. Hey, we did it in the speed challenge, at least. We messed up the size challenge, but that's fine. So the code is about as efficient as we can get, apparently. So let's look at the recoordinator now. Ah, we have a 2D array. Pawn to b6. And check. And mate. Yes, I win again. I find the game is most enjoyable playing against the best player I know, myself. Each number in the inbox is an address of the tile on the floor. Send to the outbox the coordinates of that tile, column first, row second. For example, an address of 6 has coordinates 2, 1. May I ask your boss for more examples? So this is address 6, and then we grab 2, 1 from it. All right. That. What the hell? Okay. So 0 is the start, and then 4 is the end of how far we can go. So what do we do? And we can't save these things. So for address 6, well, hold on. We can do this with division, can't we? So if we grab 6, then we're subtracting. That's in row. Well, okay. I think I see the pattern here. Maybe. So 0, 0, 0. 1 is 1, 0. 2 is 2, 0. 3 is 3, 0. 4 is 0, 4. 5 is 0. 4 is 0, 1. So 4 divided by 4 is 1, and 4 mod 4 is 0. Okay, so we're converting the, we're basically, the first cell that we're computing, the first value we're computing is the mod 4 of that number, and then the second number that we're computing is the division by 4 of that number. So 6 mod 4 is 2. And 6 divided by 4 without the remainder is 1. Which means, son of a bitch, I need to do both of those things at the same time. And, I don't remember how to do that. Okay. Well, we did it with repeated subtraction, so I guess I have to do it that way again. Alright. I mean, I did, in previous puzzles, already solve both of these problems. I'm just far too lazy to do it again. That's fine. So we inbox. This is init. And 14 currently serves no function, but we do need 14 to copy it into various things, I think. Let me look at my code for modular arithmetic and division. I could just discard the cell entirely and just do what I was going to do with the modular arithmetic and the division. So that's sort of what I'm leaning on doing, and that way I can use extra memory because this array is totally not useful to me. Alright, so this is mod. So this is going to be our base, and this is our res. Alright, so this is probably a way dramatic, not the way to do this. Fuck it. So, our mod base is 4, so I don't need this actually. But I do need to copy in 2, 0 the outbox value. So, the very first thing I need to do is compute the modular base, or compute our base mod 4. So 9 mod 4 is repeated subtraction, and at the same time we can also keep track of our div count. And the number of times we do this is the number of times that 4 goes into this value. So we copy into our base here, and let's say we have it set up like this. Okay, this is our loop. And so we have inbox, we copy it into base. So we need to, first off, we need to set our result in our division count to 0. So Do we really need to do that? Yes, we do. Okay. So we need to copy from 0, and we need to copy it into result, and we need to copy it into division count. Alright, so we subtract 4 from what we're holding, and if it's 0, then we are done. So that means we're, this is loop end. And otherwise, we do our fall through case where we bump up division count. So this, let's see what happens when I do 9 with this. So we load zeros into the results in the division. We grab 9, load it into base. We subtract 4 from 9, and we bump up division count. And then we need to copy from our base again. So we need that step as well. So we load our zeros. And we're going to need to do this not in the init part, but that's fine. So subtract 4 from 9, we get 5. We bump up division count. Grab 9, subtract 4 from it. So we don't want to jump if 0, we want to jump if negative. Which makes sense. But at any rate, we need to do both, basically, if I remember from my division and modulus stuff. So we grab 4, we subtract 0 from that. Okay, so we've reached one case here, and that's the loop end. So we need to bump division, or so we're currently holding 0, which means we need to, if it's 0, then we copy from results and we outbox what we're holding, because that would be our remainder. So instead of calling this res, let's call it rem, so that's a little bit easier to understand what I'm doing. Otherwise, if it's 0, then we just outbox it straight away. So 14 mod 4 should give us 2. This might work. Okay, if I remember correctly. So we load zeros into these, we grab 14, we do a shit ton of subtractions, and then I should be left holding 2 at the end of it, and I should just outbox that value. As you can see, that worked perfectly. So I need to not do that. So my fall through case, I'm getting really, really mentally tired very quickly tonight, so I'm probably going to stop doing this. But let's see. So after we do this, yeah, okay, I'm definitely getting like mentally exhausted right now. So kind of losing track of what I'm trying to do, but let's see if I can power through this and figure it out. So we copy 12 into base, and we subtract 4 from 12 to get 8. And we then copy, so we need to copy 2 our base, whatever we're currently holding. Okay, this should give us the remainder eventually. And then it'll probably also give us the count as well if I've done this correctly, because they're effectively the exact same thing to compute. So load 1 into base, we grab 1, subtract 4 from it, it's negative 3, and then we weren't supposed to outbox it. We've loaded 1 into our base, we didn't up the division count, so that never happened, because I should have done that here. And I think I need jump if 0 here at the same time as well. That's fine. Let's see what happens when I arrange it like this. Go have a banana. Maybe I should do that. That seems like a reasonable thing to do. So we grab 15, and we're just going to do a bunch of subtraction on that. We get 11, we upgrade div count. Okay, that's correct. Subtract 4 from it to get 7, we up our div count. And then we subtract 4 from 7 to get 3. We up our div count. We grab 3, we subtract 4 from it to get -1, which isn't right. Because then... Yeah, okay, hang on a second. I'm gonna get a banana. Oh, delicious. All right. So we don't need our 3 at any given point because 3 is I see. So base and rem are actually technically the same thing. Let's get rid of rem, and what's left over in base at the end of this is our other thing. Is our other coordinate. So once we've reached, yeah, let's run it for a little while here. And we've reached this outbox thing. So what we need to do first is we need to copy from base and then outbox that. So we grab 4, we subtract 1 from that. So we grab 1, we outbox it, and then we're supposed to also grab our division count and outbox that as well. So that's if it's 0 or if it's negative. Okay, so this is still not quite right, but it's getting closer to being right. We grab 0, load it into the division and the no longer needed base. Alright, so we subtract 4 from that. And we need to up our div count. So 4... Right, so I didn't do I did this for things that aren't 4, basically. Or things which aren't evenly divisible by 4. This currently sort of works. I know what changes I need to make, I see to do it. So we grab 7, load it into our base, subtract 4 from it. We upgrade div count by 1. Then we grab 3, subtract 4 from that, it's negative. So we're going to grab 3, outbox it, and we're going to grab 1 and outbox that. Now, we hold for here for a second, and we were given 7, which is 3, 1, as you can see right here. So this is the correct values. Alright. So now we can get rid of this copy to 1, because we don't ever actually use that value. But if it's equal to 0... So things which are divisible by 4 currently do not work. And the reason that they don't is not really... Okay, let's run this for 15, and then actually the last thing we need to do is we need to jump all the way back to the start of our function. So all the way back into init. So this will just get us to the next inputs here. And then we're going to run 8, so I'll be able to see what happens when I run 8, which is divisible by 4, so this should not work. But I need to see how it breaks so that I know what I need to actually fix. So we grab 4, subtract 4 from it to get 0. Aha. So I need to copy... So once we once it's this negative, if it's 0, I need to do subtraction. I need to copy to base and then do my test of 0, and this should do it. So we should outbox 3, 1, 4, 0, 0, which is not quite true because I need to also do my bumping of the division first and then do it. Okay. Just need to move those two statements like a tiny bit up. So 2, 3, we grab 2, 2, 0. Okay, this is looking good. Perfect. Alright. So that's my solution to this. Let's see how badly I overthought this. Oh my god. Oh no. Well, that could have been worse. I really didn't explain this whatsoever. My thoughts were completely fried. But basically what I'm doing is I'm computing the modulus of the number in base 4, then I'm computing the division without the remainder of the number by 4, which were challenges located. Whoops, I didn't mean to go down here. Those were these two puzzles down here. I just did them at the same time. They're actually the same thing to compute. That's why I was able to get away with doing it like the way I did. So that's fine.